Good day to you all. Welcome to the second lecture of tanker operation lecture series. Today we'll discuss about working exposure limit and time weighted average. At the end of this lecture, we'll calculate time weighted average. Let's begin. Let us see what is working exposure limit. As per control of substances hazardous to health, in short we call it COSH, working exposure limit are concentration of hazardous substances in the air averaged over a set period of time, right? And the working exposure limit typically refers to the maximum level of exposure that a person can safely endure when dealing with potentially hazardous conditions or substances in a workplace. Normally, we express it in ppm. However, in some gas monitor, you'll find it is expressed in milligram per meter cube as well, right? Working exposure limit is provided in the material safety data sheet for a specific cargo. So when you're loading or discharging any specific cargo, you should get this working exposure limit in your MSDS. So depending on the period of time, working exposure limit is divided in two categories. The first one we call it long-term exposure limit, which we calculate for 8 hours period. So here you see for a carbon monoxide, the long-term exposure limit is 20 ppm, whereas short-term exposure limit we calculate it for 50 minutes. For the same cargo for carbon monoxide, the short-term exposure limit is 100 ppm. So the short-term exposure limit will be always greater than the long-term exposure limit, right? Let us see what is the definition of long-term exposure limit as per COSH. As per COSH, long-term exposure limit is the maximum concentration of a hazardous substance in the air that a worker can be exposed to, averaged over an 8-hour period, aimed at preventing chronic and long-term health effects, right? Whereas short-term exposure limit is the maximum legal concentration of hazardous substance in the air, averaged over a 15 minutes reference period. Beside that, COSH also says that STL, that means short-term exposure limit, should not occur more than 4 times per day, right? So any 24 hours, the short-term exposure limit should not occur more than 4 times. Whereas the duration between two short-term exposure limit should should not be less than 60 minutes, right? So if a worker want to expose to short-term exposure limit, so in a consecutive time, so he should take at least 1 hour rest. So here we can see that the long-term exposure limit of hydrogen sulfide is 5 ppm and short-term exposure limit is 10 ppm, right? So once we get a gas monitor, we'll see that in the gas monitor we'll find that the carbon monoxide is showing, if it is normal environment, we keep it, we'll see that the carbon monoxide concentration is 0 ppm and hydrogen sulfide concentration is 0 ppm. So before you are entering to an enclosed space or a cargo tank, what you do, we just put the gas monitor inside the tank and we'll measure the concentration of that hazardous substances, right? So if we give this a tank, and we'll get this type of reading, right? So this for carbon monoxide we have got a reading of 98 ppm, whereas for hydrogen sulfide we have got a reading of 27 ppm. But we already know that for carbon monoxide short-term exposure limit is 100 ppm. So that means for carbon monoxide the worker can work 50 minutes, right? Because here we have got the concentration is 98 ppm, which is less than 100 ppm. But for hydrogen sulfide, we see that the concentration is more than the short-term exposure limit, and so that's why we need to do gas free. We need to do some ventilation to the tank or enclosed space, so that hydrogen sulfide concentration goes down. Once the hydrogen sulfide concentration goes down to 10 ppm, actually less than 10 ppm, then actually we can send our crew to to do the mopping or any other work, right? So in that way, actually, by gas monitor, before entering to the tank, actually we can see the tank tank atmosphere is okay for the crew or not, right? Let us see another important concept which we very often we use in boat ship. We call it time weighted average. We will do the calculation for the time weighted average as well, right? So what is the definition of time weighted average? A time weighted average is a method used to calculate a worker's average exposure to hazardous substance over a standard workday, typically 8 hours, right? So for example, if a worker exposed to a substance like carbon monoxide at a level of 50 milligram per meter cube or 40.5 ppm over an 8-hour shift, the time weighted average would be 50 milligram per meter cube or 40.5 ppm for uh, for carbon monoxide for that worker, right? Let us do a small calculation. So how we calculate it? If a worker is exposed to a substance at a varying level throughout the day, uh, actually you can calculate the time weighted average by summing the product of each exposure level and time spent at that level, then dividing by the total time. So let us see. Suppose a worker is exposed to a single containment during two separate processes at work, right? So in the first process, maybe in the first tank, the worker was exposed to that uh, substance, and the exposure level was 0.12 milligram per meter cube, and he was exposed for 6 hours. Then in the second process, maybe in the second tank, the worker was exposed to the same um, substance for 1 hour, and the exposure level was 0.20 milligram per meter cube. Then the worker has taken rest for 1 hour. So let us see what is the time weighted average. So what we did, we just took the exposure level which he spent 6 hours. So we just took that one and we multiplied that one. Then again we just took the second process exposure level by 0.20 into 1, because he was exposed to that substance for 1 hour. And then in the third process, actually he took rest, so he was not exposed to anything. And then we divided by 8 hours. Why 8 hours? Because time weighted average is always calculated for 8 hours, right? Then we get the result, and that is 0.115 milligram per meter cube. So the time weighted average of the worker was for the substance was 0.115 milligram per meter cube. Let us take another example. If a worker is exposed to the following toxic substance for the following periods at the stated levels, determine his time weighted average for an 8-hour day, whether or not he is within the published workplace exposure limit or not. Right? Let's see. So suppose the substance was toluene, and the long-term exposure limit for toluene was 50 ppm, and short-term exposure limit for toluene is 100 ppm, right? And the exposure level throughout the time, 8 hours time, was 65 ppm, right? So here you see the exposure level is 65 ppm, which can be more than long-term exposure limit, right? We need to remember that long-term exposure limit is calculated for 8 hours, right? But the exposure level can never be more than 100 ppm, right? It cannot be 101 ppm or 102 ppm, right? If it is more than 100 ppm, then immediately the worker has to come out from the tank, right? Now, and let us see what is the exposure profile. So at first the worker was exposed to toluene for 4 hours, then he took 1 hour rest, then again he was exposed for 2 hours, then he took 1 hour rest, right? So now we see that the worker was exposed to toluene for 6 hours, right? So what we do, actually we multiply 65 with with 6 and we get the result. Then what we do, we just divide that one with 8 hours, right? So here we have got 4 into 65, right? Because at the first phase he was exposed for 4 hours, then that's how he just he just multiplied with 65. Then he took 1 hour rest, so 1 into 0, because that time the concentration, he was not exposed to anything. Then again then uh, we just multiplied 2 with 65, because the worker was exposed to toluene for 2 hours. Then actually he took 1 hour rest, right? Then once we have multiplied and we have added all that, then what we need to do, we need to divide it by 8, right? Why 8? Because the time weighted average is always calculated for 8 hours, right? Once we have done that one, then we get the result. The result is 48.75 ppm, right, which is more than log time exposure limit, and that means the worker is safe, right? And the worker was always within the published workplace exposure limit, right? So that's actually we calculate the time weighted average for a worker or for a substance. I think that will help you to understand the working exposure limit and time weighted average better. Let me know if you have got any question in the comment. See you in the next lecture. Thank you very much.